Well, after some time of learning about exponents, how to add, how to multiply them, how to divide them, what about rational exponents? Also, any when the exponent is zero, and we've talked about scientific notation. And now it's time to turn and look at exponential functions. Now, exponential function in its parent form, let's say, takes on this characteristic right here, which is a times b, that's the base, raised to the power of x. And we're going to talk about the general characteristics and maybe a couple of transformations of exponential functions here in this Algebra 1 course. It gets a little deeper as we move forward into Algebra 2. We look a little bit more closely at some of the transformations of an exponential function. But let me just kind of give you a crude graph, and we're going to go to the graphing calculator and actually graph this 7 raised to the power of x here in just a moment. But an exponential function in its parent form, where the base is greater than 1, and that's the example we're looking at here, b standing for base. Actually, in this case, where we got 7 raised to the power of x, a is equal to 1. Okay, so it's greater than 0, but it's equal to 1 here. But this function is going to come, and it's going to hover right just so close to the x-axis, and then boom, it's going to take off like that. And it's not going to have a wavy line like I drew right there. That was just my handwriting being sloppy, but that's essentially what it is going to look like, as we're going to see when we actually graph it. Now, we're also, in addition to graphing it, we're asked to find the y-intercept and state the domain and the range. Well, let's think about this y-intercept first. If algebraically, if I'm going to find the y-intercept, I set x equal to 0 and solve. Well, if I put 0 in for x, which is that exponent, well, anything raised to the power of 0 is equal to 1. And so I'm going to have a y-intercept when x is equal to 0, y is going to equal 1. And perhaps we can visualize that that's about where that's going to occur, assuming that's 1 right there. Now, what about the domain? Well, once again, as x is going out here to a negative infinity, we're getting really, really close to 0, but we're not ever going to go below 0. And let's think about why that is. Let's say that I've got 7 raised to the negative first power. Well, we know by now that that also is equal to 1 over 7. Well, that's still a positive number. That's not a negative number. Well, what about if I got 7 raised to the negative 2 power? Well, that's 1 over 7 squared, or that's 1 over 49. Well, that's a smaller number than 1 over 7, but it is still greater than 0. Let's see, what about if we had 7 raised to the negative 5th power? Okay, 7 raised to the negative 5th power would equal 1 over 7 to the 5th, which is 1 over 16,807. Now that's getting to be a really, 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 really small number, but it's still greater than 0. So my domain then is going to be all real numbers, all real positive numbers, all real positive numbers. No, excuse me. I'm thinking about my range. My domain is going to be all real numbers, period, from negative infinity out to infinity. Uses a little abbreviation for numbers, so it's going from negative infinity out to infinity. Now, I almost messed up there because I had my mind on the range there for a moment. What about the range? Well, what were to happen if somehow, and it couldn't happen this way, if I had 1 over 0? Well, that would be undefined, right? If I could raise 7, in this case, to some power, that would give me 0. it would be undefined. So my range has got to be y, let's put it like this, such that y is greater than 0. It can't equal 0. If it equaled 0, it would be undefined. So let's go to the graphing calculator. We're going to graph this, and we'll take a little bit deeper look based upon our actual graph. Well, here we are. I'm on my graphing calculator, and we're going to graph this function 7, this exponential function, 7 raised to the power of x. It's an exponential function because my variable is up in the exponent. And, you know, it's always a good idea before I start something new that maybe I go and take a peek at my window. I see I'm in kind of the default mode or the standard mode. In fact, if you hit zoom standard, it would bring you to exactly what you see right here. And sometimes I do some stat plots. Maybe I want to make sure those are turned off, because if they're on, I'm not going to be able to do what I want to do. So we're going to graph this function, 7 raised to the power of x. I'm going to hit 7 caret, and then I'm going to put the x in here. And hit the graph button. All right, and there you can see that as we're coming from negative infinity, as we're coming from the left-hand side, moving towards the right. In fact, it even looks like I'm at x equals 0, but I'm really not. It's just so close that the way my window is set, it really can't distinguish how close it is. And we'll look at the table in a moment and show that that's true. And then we come up here, and as we're getting towards the y-axis, we begin to start moving upward. And right there, where x is 0, and y equals 1, we see that y-intercept. Now, we don't have an x-intercept. In fact, let me introduce this to you, and you'll get more into this in Algebra 2. We actually have what is called a horizontal asymptote that runs along the x-axis for this function. In other words, we cannot go below 0. And after we hit the y-intercept up here, you see we take off, and we take off really fast. Well, think about it. 7 to the first power is 7. 7 squared is 49. My maximum viewing window here on the y-axis is y equals 10. So I'm off the scale really quickly. Now let's go look at our graph, our table, and see what we can learn from there. Well, I can see here that when x equals 1, when x equals 0, y equals 1, there's my y-intercept. And then I can see that as x is going more and more positive, let's look at, what about when x is equal to 7? When x is equal to 7, y is equal to 823,543. Now that's taken off really fast. Now let's look at some of the negative, when I got negative exponents. Well, when x is negative 1, that's 1 over 7, and that actually in decimal form is 0.1429. And when x is negative 2, it's at 0.0204. You can see it's getting close. It's getting closer to 0. Let's scroll this thing up and look at some more negative numbers. Oh, how about when I get even to x to the 4th? I'm at 4.2. Scientific notation times 10 to the negative 4th. That means I'd move that decimal 4 places. If I move that 4 places, that's going to be 0.00042. Now that's getting to be a really small number. And you can see that x to the negative 5th is 5.9 times e to the negative 5th. Remember, that's putting you in scientific notation. That's really 5.9 times 10 to the negative 5th power. We'd move that decimal 5 places to the left. That means I'd have 4 zeros sitting in front of that 5 after the decimal point. Getting really, really small, but it's never going below 0. So my y-intercept is at 1. My domain is all real numbers. There's nothing that's restricting my domain. But my range has got to be greater than 0. It can get really, really small as x gets more and more negative, but it's never going to drop below that x-axis in its parent form. Now, we can have some transformations. We're actually going to look at one, I think, in a minute. that'll cause an adjustment to the range, but it's not because of the exponent. It's because of some other factor where we actually have a vertical shift downward. Learn to use your calculator. Play around with it. You really can't hurt it. By playing around with it, you learn from it.